So what is the null hypothesis for the significance test comparing two population proportions? So H is P1 equals P2.
Right. What is the formula for a test statistic for testing two population proportions? Explain what each variable stands for in your formula. Z equals
I know. It's
minus P2 hat. That's ridiculous. Minus P1 minus P2 divided by the square root of P hat times 1 minus P hat times 1 divided by N1 plus 1 divided by N2. And N1 is a sample size for group 1, N2 sample size for group 2, P1 hat sample proportion for group 1, P2 hat sample proportion for group 2, P hat overall sample proportions.
right. Right. So then what is the confidence interval for comparing the two proportions? So P hat 1 minus P hat 2 plus or minus Z star the square root of P hat 1 times 1 minus this P hat 1 divided by N1 plus P hat 2 times 1 minus P hat 2 divided by N2. So P hat 1 is the sample proportion for group 1, P hat 2 is the sample proportion for group 2, and N1 is the sample size of group 1, and N2 is the sample size of group 2, and Z is the Z value for our confidence interval.
Oh, awesome. Okay, use the following data summary to answer questions 4 through 6. Women 296, sample size 296, X 63, men 251, 27. There was a recent survey taken on whether consumers are label users who pay attention to label details when buying clothes. Are men and women equally likely to be label users? Determine if the proportion of men who use labels are different than the proportion of women who use labels with a level of significance of 0.05. Check the requirements. So 296 times 0.213 equals 63, which is greater than 10. 251 times 0.108 equals 27, greater than 10. 296 times 1 minus 0.213 equals 233, which is greater than 10. And 251 times 1 minus 0.108 is 24, which is greater than 10.
Yep. So state the null and alternative hypothesis. So the null hypothesis is P1 equals P2, and the alternative hypothesis is P1 is not equal to P2.
Awesome. Okay, so for this next one, the test, compute the test statistic, I tried and I could not get it. I could not get this answer. It's that same, it's a huge equation. That's probably why I was just doing something wrong, I'm sure. Right? It's the one, the long one, right? The P.
Right.
Yeah.
And I used the Excel spreadsheet, so.
Oh, you did? I just have to do that.
Yeah.
Ridiculous. Okay, so, but the answer was 3.309, and I know how to do it, I just couldn't get the answer. I think that I just needed to be more accurate with the way I was doing it.
I know, I was just like, I should have done it tried it with the formula.
So hard.
Yeah.
So hard with so many numbers. With so many numbers, it's like, it's hard to know if you're getting the right answer. I mean, with the answer sheet, it's nice, but like, you know, to be able to compare to see if you get the right answer, but
right.
I do not know how many this test, because
right.
Ridiculous.
So the p-value was 0.001, which was, it was like to the -4 or something like that, right? 0.0009 something to -4. So 0.001.
Okay, shade your p-value on the normal distribution curve with a test statistic labeled. That's just.
What decision do you make about the null hypothesis? Reject the null hypothesis because 0.001 is less than 0.05.
State your conclusions in layman's terms. We have sufficient evidence to say that there is a difference in the proportions of men who use labels and women who use labels.
Yep. And so if you can construct the a 95% confidence interval for the difference of the two proportions, it's 0.045.166.
and interpret the confidence interval you constructed in number 5. We're 95% confident that the true difference in the proportions of men being label users and women being label users is between 0.05 and 0.166.
Yeah.
Awesome. Okay. Let's just hope that they don't have crazy questions on this. I'm sure they will.
No. Well, I have the spreadsheet open, so, well, almost open.
Okay.
Just thinking about it. Okay. Oh dear. Okay, let's see. For the next 9 questions, we'll review the PTC tasting study with different data. Out of 70 females in the sample, 52 can taste PTC out of 59 males, and 42 can taste PTC. Uh-oh, for some reason, mine is not giving me.
It's not showing you the data?
No.
Oh, I can tell you what it is. That's weird.
Yeah. It says, please
It says,
data here. Go ahead.
and then it doesn't say the data there for you?
It just has a picture.
Oh, really?
Yeah. Like a.
Oh, wait. Mine says, so the first section, can taste PTC, no, yes, and then total. So for female, 18 can't taste it, 52 can, and 70 total. For males, 17 cannot, 42 can, and 59 total. I can reread these to you. And then total, 35 can't, 94 can, and 129 total.
All right, so hold on.
I can try to, how do I screen share with this?
Here, let me just write it down. I got it. Oh wait, that's not what I wanted to do. Hold on. Okay, so for males,
Can you see this right here?
Hold on. Yes. Yeah. Okay. Good. Females. Yes. 52. No. 18. Total 70. Males. And it's 42 males. 17, 35. What browser do you use? Are you using Firefox or Explorer? Oops. Did I lose you?
Shoot, I don't know what just happened. That was weird.
That was weird.
Did you get it all, or do you need me
I
to
did.
share it again?
No, I got it. Okay.
That was weird. At least it got us back on the call. That was funny.
Okay. Okay, so use the data table to find p hat 1. So P1 be the proportion of females who can taste. So it's females, yes.
Okay.
52 divided by 70.
743. Right? Okay. Use your data in the table to find P2. So how did you, does it say in there that the P1, that would be the total, like the yes? Oh, I guess that's what we're trying to find.
Right.
Or what?
Yeah, be the, yeah. So P2
Right,
would be
because
the
can
males
taste.
who can taste. Yep. So males who can is 42. Wait, what was
Yeah,
the total? I missed the total.
59.
So is it for males? Was it they can taste is 42 and can't is 17?
Yes, and total is 59.
I don't know where I got 35. That's weird.
35 is the actual total that can't.
Okay, so 0.712.
Uh-huh. Okay. Was it me? I don't know. Which set of hypotheses is appropriate for addressing the research question? I'd say it's the
Difference. So we want P1 equals P2 and the alternative P1 does not equal P2.
yeah.
Create a 95% confidence interval for P1 minus P2 or well, P1 P to P2. Input your answers for the point estimate, margin of error, lower bound and upper bound. So if X is analysis 42, 95. Oops, wait, on that one. Hold on. P1 is not equal to P2. All right, so point estimate. So is that the 1.96? Is that what the point estimate is?
I think so. Let me look at the, so for the homework, when did we have to point estimate for the homework?
I don't remember.
I think what this one is, so let me see. Do not remember what the point is. So
Yeah, I'm looking at the book right now.
let's see. So So p hat is called a point estimate of p. The sample proportion p hat is 1 point on the number line that estimates the value of the true proportion p.
Hmm. Well, I guess that's about all I can think of is that 1.96. That's what Z is.
Okay, yeah, let's just put 196. Let's just put that in there, and I guess we have another try if we need.
Yeah. So if we do so if you do the lower bound, if we skip 7 for a second and do the lower bound is negative 0.123. And the upper bound's 0.185. So to figure out the margin of error, you add those two and divide by 2, right?
Sorry, you're broken up. Can you hear me?
Yeah, I can hear you. Oh, sorry.
Okay, you were broken up the whole time that you're talking. Sorry.
Okay, so I was saying that if we have the lower bound, which is negative 0.123, and the upper bound, which is 0.185, if you add those two together and divide by 2, that gives us the margin of error. Is that right?
Yeah. What did you say the bound was? You were breaking up.
Okay, so the lower bound is negative 0.123.
Okay.
And the upper bound's 0.185.
Awesome. So
So with alpha equals 0.05, what decision do you make?
did you get 0.031 for the margin of error?
Oh, yes.
Good. So we reject. No. 0.031 is I always get, so yeah. You reject it, right?
Well, I thought when we were figuring out confidence intervals that Oh, this is, now I'm really confused because if it includes 0, you have to fail the reject. The p-value is 0.693.
Uh-huh.
So it's the p-value is greater than 0.05.
Okay.
So we failed to reject. The null
Okay.
hypothesis.
Okay, and so which of the following statements best describes the outcome of this study? There's, let's see.
Insufficient evidence to suggest that cheaper.
Maybe insufficient evidence suggested that it is different from the true proportion.
Right, right, insufficient evidence. Why is this not reading? I've never had any problems with Chrome and these quizzes. I don't understand why it's not reading it today.
Here, I'll share this with you again.
Okay. So you'll have to talk.
So, yeah, for the next 9 questions, we will review the mortality rates of day of admission heart attack study with different data. Out of, 118,519 who had a heart attack during a weekday, 16,713 had died. Out of 42,447 that had a heart attack on the weekend, 6,155 had died. Please use the data presented here. Let P1 be the proportion of patients who died of a heart attack and were admitted on a weekday who died, and let P2 be the proportion of patients who had a heart attack and were admitted on a weekend who died. The research question for this study is given here. Is the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who died less than the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who died? Use a significance level of 0.05. Then the question is, the conditions of conducting a hypothesis are satisfied.
Double check and make sure I wrote everything down right. 8, 5, 9. And okay.
Okay. That was a lot of words that I not.
Okay. So P1 be the proportion of patients who had a heart attack and were admitted on a weekday. Who died. Okay, so the weekday who died. So X1 is 16713, and the total of that is 1.8519, and X2 be the portion of patients who had a heart attack and were admitted on the weekend who died. The weekend who died is 6155. And the total of that is 42447. And then we wanted the research question for the study is given here. Is the proportion of patients who have a heart attack and are admitted to the hospital on the weekday who died less than the proportion of patients? So we want P1 less than P2.
That's true.
Okay, so check for requirements. So first sample 16713 is less than or is greater than or equal to 10, and 101806 is greater than 6155. So yes, the conditions for conducting hypothesis tests are satisfied according to the spreadsheet.
Which set of hypotheses is appropriate for addressing the research question? So that would be, on the weekday, less than the proportion of patients of heart attack, but that's on the weekend. So maybe equals or less than.
Right. Use the data in table 1 to find p hat 1. So p hat 1 is 0.141.
Mm-hmm. Then 0.145 for p hat 2.
Yep. The z-score is negative 2.02.
Is there another decimal after that? It says down to 3.
It says 0.
Oh, okay. Never mind then. Given the z-score from the last question, which should you shade, the left or the right of the z-score for the p-value?
We're doing less than, so we do the left. And so the p-value is 0.022.
What is the decision for this test? So it's 0.022.
Yeah, right?
Yeah.
So which of the following best summarizes the conclusion for this test? Okay, there's sufficient evidence to conclude that the portion of patients who have a heart attack and are
Is less than the proportion of patients, right?
yes.
Okay. Oh, we got a couple wrong. Numbers 6 and 7 wrong.
Thought we might get 6 wrong, but number 7. All right, so
Okay, let me know when you're ready so we can go through these again.
okay. I have a lot of tabs open here, sorry.
Yeah.
Okay. Oh,
Okay.
this time all the tables showed up. That's so weird.
Oh,
Okay.
how funny.
Yeah. Okay, number 3.
Number 3 is 0.743. Number 4, 0.712. Number 5 is P1 equals P2 and P1 does not equal P2.
Okay.
Number 6 is where we need to figure this out. Is this like the same as like, how would it be like point something comma point something? Do you know what I mean? Like the interval? I guess it wouldn't be because it's the point
No,
estimate.
that's the margin of error. Okay. So it says okay, just a sec. So the point, okay, I'm looking back at a different one. So the P hat is called the point estimate of P. The sample proportion of P hat is 1 point on the number line that estimates the value of the true proportion P. So P is the point estimate. So P is the point estimate.
But P1 or P2?
I know
Is
that's
it just P1 minus P2? Is that what it, because it says that we create the confidence interval for P1 minus P2, but
I know we have 2 P's.
we have, if we subtract it, if we do, so P is just the sample total, right? Is that what P is, the whole sample?
So would it be P1 plus P2?
It could be minus. Let me see. I think it would be like 52 minus 42. I don't know. Because it'd be the total sample size for females, 52. Actually, the total sample size. So it'd be 70 minus 59, right? I have no idea.
Oh, we don't even use P in this formula.
No idea. Well, it says let P1 be the proportion of females in the population who can taste PTC, and P2 be the proportion of males in the population who can taste PTC. So it'd be 52 minus 42.
Hold on.
That's it.
Here's what I'm gonna do.
The 95% confidence interval for.
I'm going to go and see. I mean, because we need to know what this is. This isn't like.
Yeah.
I'm going to go to his meeting and look and see if he explains what the point estimate is.
Okay, as I was saying.
Okay, so what number is this again? Number
we need
6?
the confidence interval between the proportions. We know the confidence interval. I just copy down and up or down. So we have all of the formula. Let's just do this.
Put your answer for the point estimate, margin of error, lower bound.
Okay.
What is the point estimate for this 95% confidence interval?
Now, from one proportion, we know the point estimate is just when we were doing the one proportion. The point estimate is the sample proportion. Now, when we're doing two proportions, the point estimate is the difference between the two sample proportions. So, since we already computed the P1 and P1 half and P2 half, bring this again. So
I think it's 52 minus.
It's P hat minus P2 hat.
Minus P2. And let me see, I think I did not include it here. I'm going to might as well include that here. Let me insert.
So it would be 0.743 minus 0.7712.
So this is
I'm making sure that's what he's saying here.
P1 hat. I should put this in parentheses.
Oh.
Number 7.
Okay, so yeah, so he's saying P1 hat minus P2 hat. So point,
0.031.
yeah. Then let me see how he does the margin of error, because that's the margin of error that we got, right?
That's what we got for the margin error, but I just did it again. I just did that divided by 2, and I got 0.387. But you should see what he says because
Okay.
What is the margin of error for the 95% confidence interval?
So going back here, we already have since we have 95, so we put in 0.95. And then the margin of error is in E, there it is. All the formulas that I showed you, it's already built in here, okay? And therefore, the margin of error is just that. We just copy and put it here.
Oh, you know what? He has a different spreadsheet.
he does.
He does. It actually shows the margin of error,
Oh.
which is probably the one that he gave us on the that's not what I want to do. Yep, it shows us the margin of error here, which was a big old long formula, which wasn't in the they didn't give us the margin of how to do the margin of error in the lesson plan.
Weird.
So X1 was, what was X1? Sorry, I just closed my other spreadsheet. X1 was weekday died 16713. N1 was 118519. X2 is 605. And 2
But are you looking at
am I looking at the wrong one?
yeah, we're
Yeah.
still doing the no taste PTC.
It was can. Was it can
So
or can?
can taste. So 52 for females
2.
and 42 for males
Okay.
who can taste.
42 and 59. And what did we do? Females first or males first?
Females.
2 and 70 and 42 and 59. So confidence was 95, right?
Yes.
So the margin of error is 0.154.
Okay. Okay, and then lower bound is negative 0.123. Upper bound 0.185. And fail to reject, number 10. 11, there's insufficient evidence to suggest that the true proportion of males who can taste PQT is different the true proportion of males who can taste it. Number 12 is true. Number 13 is equal to or less than. 14.141. 15.145. 16, negative 2.02. 17 is to the left. Number 18 is 0.022. Number 19 is reject the null hypothesis. And number 20 is sufficient evidence to conclude that the portion of patients who have heart attacks are admitted to the hospital on weekday who die is less than the proportion of patients who have a heart attack and are admitted to the hospital on the weekend.
All right. That was
Great.
better.
Got it.
Well, at least now we know what the point estimate is.
True. Yeah, that's good. Okay, cool.
Nice.
Well, then I will see you on Thursday.
Yes. Sounds good. Okay. Thanks.
Yep, have a good day. Bye.
Bye.